Yes, today we can discuss about truss element. Trusses in finite element analysis. A truss is defined as a structure as like this figure which can be constructed several bars. The bars may be connected with 1 to 2 and 2 to 3. Likewise, several bars we needed to make a truss. All the trusses are riveted with each other. All the trusses are riveted with each other. The assumptions to solve the truss problem in finite element analysis are: first, all the members are pin jointed. So, all the joints are considered as pin jointed. After that, all trusses is loaded at only the joints, not intermittent. Only the joints, only load is acted. The self weight of the members are neglected for solving the problem. Now we may understand what are all the assumptions we should consider for solving the problem with the aid of finite element analysis of truss in one dimensional problem. In that, first, how can we solve, what are all the equations we utilized? Let's see. In this, I consider the first node and the second node of the element. It may have some angles, so that I can draw like this. This is first node I considered. This is second node I considered. Other things, the first node may be called as x1, y1 points, coordinate points, and the second point coordinates are x2 and y2. Now I can draw the vertical line and horizontal line, so which makes some angles which is known as theta. Here, what is the distance of this vertical line? Yes, I can calculate from y2 minus y1. From this I can identify the distance of the line to this may be called as O, means 2 to 0. After that, what is the distance of this 1 to 0? Yes, which can be calculated from this x2 and the x1. So x2 minus x1. Likewise, I can calculate. After that, it has two directions which may be called as L and M. So directional cosines are L and M. How can I identify this L and M? Yes, M is always opposite to the angle making the element, okay, and L is the adjacent side. So how can I identify the L and M? L can be called as L is equal to cos theta. From this diagram, how can I identify the cos theta? Yes, cos theta is equal to adjacent side by hypotenuse. Here hypotenuse called as LE. So adjacent side is x2 minus x1. So cos theta is equal to x2 minus x1 divided by hypotenuse. What is hypotenuse? LE. Likewise, we can calculate. After that, M. Well, how can I identify this M? Yes, M can be identified through this angle. So the M, which is opposite side, which can be called as sin theta. So opposite side, what is the opposite side of this angle? y2 minus y1 divided by hypotenuse, which is LE. Likewise, we can calculate. Then how can I identify the hypotenuse LE? Yes, which can be calculated from the square root of x2 minus x1 square plus y2 minus y1 square. From this formula we can identify the hypotenuse value, because the square root of adjacent side square plus opposite side square, which is the hypotenuse formula from trigonometry. From this we can write the formulas like LE is equal to x2 minus x1 square plus y2 minus y1 square. After that, the important thing is to write the stiffness matrix. What is the stiffness matrix of stress? Yes, stiffness matrix may be called as K. So stiffness matrix AE divided by LE. The formula for Stress L square Lm minus L square. Already how do we identify the Lm? In previous slide we discussed. Minus Lm, that Lm m square minus Lm minus m square, minus L square minus Lm L square Lm, and another fourth row is minus Lm minus m square Lm m square. From this we can easily identify the stiffness matrix of the given problem. The problem may utilize to identify the force etc. means F is equal to stiffness matrix into stiffness. From this we can identify the force applied on the truss element, which is the formula we can utilize to identify the truss element structure analysis. Thank you all. If you are having any doubts, you may ask me through comment box.